Assalamualaikum, my name is Anwar Fitri Iskandar bin Johor. I would like to share my reflection video of a transformers. In the theory, transfer electrical energy from the one circuit to another through inductive coupled electric conductors. In reality, more than simple electromagnetic device, but have a complex equipment and many functional components. So, in the diagram, transformers in electric network. Okay, in figure that application on transformers. One is power generation, second wind and solar power generation, third is transmission and distribution. Okay, fourth commercial and residential uses. 5 railway application, 6 is oil and gas application. In this figure also has a transformer type. One is power transformers, second dry or special transformers, third is power and distribution transformers, 4 dry and distribution transformers, and 5 is dry or special transformers traction. Okay, and 6 is subsea transformers. Okay, there also have 6 transformers type is 1 railway, second is oil and gas, okay, third industry, 4 generation plant, and 5 transmission, and 6 distribution. Why transformer is very important? Okay, 1 is failure power interruption, 2 is critical asset in electrical network, third is a safety people equipment, okay, 4 highest capital investment. Okay, cost of unplanned outages. Okay, what we can see is cost of power, but for the unseen is environment impact, loss of production, transportation, and reputation.
Warahmatullahi wabarakatuh. My name is Abdul Wafi bin Abdul Rahim from BEA 1/1. I would like to share to you about the transformer insulation system. Power of transformer insulation system consists of two primary components, which is liquid and solid. For the liquid was the oil insulation, and for the solid was the paper insulation. For the oil insulation was it was act to be as a coolant, dielectric, drying and information center. For the paper insulation part was to provide the mechanical strength, provide the physical isolation of conductor at different potential in insulation system. For the mineral oil, it is the most common use is isolating liquid. It was to use because of it was readily available, cheaper, long service history and use, and safe to use. Next, I will explain about the solid insulation. For the it was next I will next I will explain about the solid insulation. Cellulose fiber manufactured from coniferous woods and other vegetable sources. Wood is treated with sodium hydroxide and sodium sulfates in aqueous solution at 160 to 175 degrees Celsius. And the final composition is 90% cellulose, 7% pentylcellulose, and 3% lignin. For the advantages for the insulation in transformers, it was highly mechanical strength, flexibility, and low cost. For the limitation for the insulation, it was inferior electricity to strength, low thermal conductivity due to air field gap between fibers, and high hydrosity due to developed surface of fiber that can readily absorb. Lastly, for the degrading of insulation system, insulation material may be degraded under operating conditions, becoming unable to carry out properly works and increasingly the probability of undesirable outages. For deterioration is primarily a function of temperature, time, moisture, and oxygen content. For the most critical part was the paper insulation. That's all from me. I would like to share about to the other panel. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najmi Ashraf bin Ahmad Nazri and I would like to present on the condition monitoring of transformers. Okay, so there are summary on this info, which is the first one is it is also known as condition based maintenance. Next, it is told that the majority of failure does not occur instantaneously but develop over a period of time. Next point, activities are designed to identify a specific characteristic change that is indicative of a future failure. There are two-step process in this condition monitoring. The first one, monitor any significant change in parameters, and the second one, initiate a maintenance task when a change is detected. The objective of this condition monitoring is to monitor the condition of transformers and provide an early warning of fault. Next is to diagnose a problem when transformer exhibits signs of distress or following the operation of protection equipment. And the last objective is to determine whether a transformer is in a suitable condition to cope with unusual operating condition. Move to the next point, which is condition monitoring general definition. It is inspection and measurement of plant parameters and the recommendation of actions based on the information gained from these parameters to increase the probability that the plant will continue to reliably perform its function. The next point, which is transformer diagnostic testing. There are 6 points in this testing. The first one is bushing, next is step changer, tanks and associated device, core, winding, and insulating oil. Move to the first one. The bushing include testing of capacitance, dielectric loss, partial discharge, infrared thermography. Next one, step changer. The test include its ratio, dynamic resistance, motor current, vibroacoustics. The next one is tanks and associated device. Visual inspection, infrared thermography, and calibration are included in this testing. Move to the next one, insulating oil. The water content, dielectric strength, acidity, interfacial tension, dissolved gases analysis, and furans are included in this testing. And move to winding, capacitance, dielectric loss, partial discharge, insulating resistance, ratio, polarity, phase, winding resistance, FRA, RVM, FDS, PDC, and UP are testing in winding. Next one is core, the excitation currents and insulation resistance. Transformer condition assessment include 2 conditions. Transformer condition assessment are include oil analysis and electrical analysis, and that will be discussed by my teams. That's all from me. Thank you.
Assalamualaikum and hi, I am Muhammad Nawar bin Awang Kasim. So I'm to share my reaction video on the talk 1 in the subject engineering seminar. So my part is going to share the transformer condition assessment in oil analysis. So in the oil analysis, it divided in 3, which is oil quality analysis, second, dissolved gases analysis, and third, life assessment. For the oil quality analysis, it involved in testing of insulating oil, which divide in 3 groups. For group 1, testing for color, appearance, breakdown, voltage, water content. For group 2 is sediment and sludge, interfacial tension, and particle count. Third group is check the oxidation or stability, flash point, compatibility, pour point, density, and so on. The second analysis is dissolved gases analysis. Thermal and electrical fault causes deterioration and decomposition of solid or liquid insulation. So degradation process involved in gases product dissolved in the oil. Gases can be quantified by dissolved gases analysis (DGA) technique. It allows the prediction of fault and fault type. the last analysis, which is the life assessment, which divide into physical of life and economic end of life. In the talk, only mention the physical end of life, divide in also two, which is diagnostic test and thermal evaluation. That's all for me. Thank you.
Hello, my name is Muhammad Noabra and I will explain on dielectric response analysis. Moisture is the most powerful agent of paper degradation, leading to the lowering of degree of polymerization and resulting in information of decomposition product. Important to determine the level of moisture in transformer in order to prevent further degradation. Whereas the water, most of the water is contained in the cellulose. More important to measure the water content in paper than oil. And how to measure water in paper in solution? There is no practical direct way of measuring moisture levels in transformer insulation. Therefore, a wet condition may go unnoticed for a long time. This has led to an indirect method of moisture estimation. The direct method take paper samples from transformer and test for moisture content using KFT. Limited use since possible during repair or teardown. An indirect method is to measure properties of the insulation which can be related to moisture content, moisture in oil measurement, and also electrical method, dielectric response. For the dielectric response measurement, the techniques that are available, and that is frequency dielectric spectroscopy, FDS, polarization or depolarization current, PDC, and also recovery voltage measurement, RVM. And that's all for me. Thank you.